Hi, my name is Phil Quade. I'm the CISO of Fortinet. We'll talk a little bit more about business in a second, but here's roughly the outline I'm going to talk about today. But one of the things that's going to be the focus of what we're talking about is something called OT, operational technology. Do you guys speak this language, or is OT mostly new? I don't want to talk down to you. Anybody really deep in OT? Show of hands. Okay, at least one. So operational technology, as opposed to IT, information technology, are the things that control physical processes and things. It's used in industrial automation, and it's often used in the 16 or 17 named critical infrastructures in the United States. So think electric power, generation, transmission and distribution, oil and gas, upstream, midstream, downstream, water treatment, dams, et cetera, et cetera, et cetera. So they control physical processes and things. That's OT. And in terms of what are the different words you hear associated with OT, I thought this diagram might be helpful as well. I don't know, 20 years ago, everyone called this SCADA, and then we kind of migrated to the term ICS, Industrial Control Systems. But the broader term is operational technology. CI is critical infrastructure. OT is used within CI. Sorry about that, getting used to my new remote control. And architecturally, here are the major elements of an OT network, right? So when you're running an OT network, it's fundamentally about not confidentiality, integrity, availability. It's about safety and reliability. So you have a safety part of your network, and you have a control part of your network that's actually controlling stuff that does things out on the plant floor or out in the field. And as I mentioned earlier, IT and OT are very different. If you go to a conference or a large gathering of OT people, it's completely different people. Like in this group, we have, I think I counted one hand raise their hand who said they're kind of deep in OT. It's different people, different experiences. They have different jokes even, right? The OT and the IT community are very, very different. Maybe they like the curiosity kills the cat joke. That's a transcends community. But if you're in the IT field, it's mostly about manipulating information. But in the OT space, it's about physical processes and things. There's a lot of standards in the IT world. The OT world, not so much. And then, as I mentioned earlier, in the IT world, it's mostly about C, I, and A, right? Confidentiality, integrity, and availability. But in the OT space, it's all about safety and reliability. So where we IT folks might err is by going into the OT space and saying, let me tell you how to do your cybersecurity. And they'll say, thanks very much, I've been doing just fine. And it's because we come from different perspectives, different backgrounds. So from a threat perspective, this was the major threat for the past 50 years. And what I mean is that the threat to these physical systems were mostly about backhoe accidents in rodents, squirrels, if you don't think squirrels are rodents, but rodents chewing through things and destroying physical things. So that was the threat for a long, long time. And unfortunately, that's just not the case anymore because these critical infrastructures have become targets of foreign attacks. And why is that? It's because data has become the oil of the 21st century, right? So for the past 100, 150 years, the national powers have been the countries that are ones who could find oil, extract it, do good things with it, and protect it as well. Well, you could probably use a lot of those same words today regarding data. So we've become very much a data-centric economy, including the critical infrastructures are depending on those data systems. All right, so taking a look back at the different types of societies, right? We all remember this from probably middle school or so. We have different types of segments in our history. And all of us in this room have certainly lived through the service economy era, and now, of course, it's the data economy era. And this particular presentation is more focused on maybe those top two areas. What comes next after the data society? And I don't have a name for it yet, but it might be the cyber-physical society. It's where cyber and physical things kind of emerge or converge. And that's what's going to be the focus of today's talk. All right, so we will spend a little time on threat. So let's see. 15, 20 years ago, President Bush and Cheney came out to my organization to kick the tires on the SIGINT system at NSA. And we told them, after that was done, we said, look, there's more that we could do to help protect the United States systems. Do you want to hear more about that? But NSA didn't have the authority to do those types of things, right? NSA is primarily a foreign intelligence agency. So to their credit, they said, yeah, tell us more. We created a project that also became a national program that they funded at the $17 billion level. So $17 billion over 5 years. And it was a new strategy at the time, and it was to do something called active cyber defense. It was to detect and mitigate in cyber relevant time. Rather than just sort of hunkering down and waiting to be hit, you would detect and mitigate before really, really bad things happened. Informed by specialized intelligence to kind of supercharge capability. And so NSA's role in executing that, so my office was getting about $2.5 billion a year to execute the foreign threat part of that. And the threat, so active cyber defense at the boundary, so that was the strategy at the time. It was create a physical and virtual boundary around government networks, do active cyber defense there, informed by specialized threat information. And boundary defense, which we'll talk about later, is dead or dying for the reasons we all understand, that it's really hard to define a boundary today in the age of wireless cloud mobility. But what hasn't changed is you want to make sure you understand the threat. So the threat, of course, today has changed. 50 years ago, it was about bullets. Today, it's about bits. We used to worry about the Fulda Gap and military targets, but now it's our economic foundations, including the critical infrastructures. And why might adversaries choose to do this? You see it over there. And it's not just a hypothetical anymore, right? So that's what I mean. I didn't want to be a fearmonger. I didn't want to be the divorce lawyer sending out the Valentine cards, fake Valentine cards. This stuff is real, right? We've seen Russia do it many, many times. They're capable, they're willing, and they're motivated to do this type of things. And whereas, I'm just going to diverge for a second, where it's, I don't want to say easier to manage China from a national perspective. So in my last few years, I worked down at the White House and to help define national strategy and policy on cyber. And there's the Chinese problem, right? A very, very aggressive and capable cyber adversary. But the Chinese, you can influence through shaming, right? Culturally, they respond to shaming. And then economically, they're a good citizen in the world stage, right? They're motivated to make the world economy act. So you have some levers to pull. Not so much with Russia, right? They're not a member of the world economy in any big way, and they can't be shamed. And so Russia really is the big adversary here when it comes to critical infrastructure influence. Don't get me wrong, other countries have motivations and some capabilities, Iran, North Korea, but it's pretty much a four-horse race. Russia, China, Iran, North Korea, with Russia leading that pack. All right, so we all know the phrase, all roads lead to Rome, right? This is obviously a made-up diagram. Does anyone know what the phrase means, what it generally is tended to mean? All roads lead to Rome? Anyone want to take a guess? I won't embarrass you, don't worry. Has a couple different definitions. It means that there's lots of different ways to get to a problem. Another definition is the emperor is, I never say this word right, omnipotent, all-powerful, right? So those are the common definitions of all roads lead to Rome. But it also turns out to be, in addition to just a graphic here, the actual case in parts of Italy where you can get to Rome in lots of different ways. But history has shown that it turned out that these great critical infrastructures that the Roman Empire built many, many years ago to spread commerce, to spread culture out from the center of Rome, turned out to be Rome's downfall. And what I mean is that these great paved roads became the methods that Mongols and other tribes and adversaries used to quickly get into Rome and ultimately led to its downfall. Now, I've got to admit, it's a pretty cool graphic until I realized that actually there's some jokes on here that I missed. It's not the case that the Kardashians and the giraffes invaded Rome down these critical infrastructures, but it's still a good graphic that showing that it's the critical infrastructure of its day led to the downfall of Rome. And I think it's a good analogy today that we built these magnificent infrastructures that support our economy, our government, our pursuit of safety, and not pursuit, our pursuit of happiness. And if we don't take better care to secure them, it can lead to our downfall. And if you don't quite believe that cyber can have effect on physical. Here's an example of an accident, not an attack, an accident in a former Soviet state at a water plant, hydroelectric plant. You can see the different large pieces of equipment. And during maintenance, during a shutdown, some people put in out-of-range parameters. And it caused things to explode, right? Vibrations started happening. Water was released. It caused an explosion of steam. And you can see the massive scale of damage that it caused, both in the photos and in the numbers itself. And this is based on bad bits. So bad bits cause a physical effect. So this idea that cyber and physical are unrelated is not true. And this is just a very graphic way of showing that. All right, so I might embarrass you with this one, but I won't make it personal. So how many? So encryption, it truly is a silver bullet in the IT space, right? If you had a single triple DES encrypted message, so strong, large key triple DES sound algorithm, how long would it take to brute force that message? Anyone want to take a stab at that? I need someone. Give me a brave soul. How long would it take to brute force a message?
12 minutes.
Pardon me?
12 minutes.
12 minutes. Okay, thank you. So it would take, to brute force a single triple DES encrypted message, correctly encrypted, it would take all the computers on Earth longer than the age of the universe to break that message. And what I'm trying to say is that strong encryption, correctly implemented, is a silver bullet in the IT space. It's a really big deal. It's great. You got to correctly implement it. It's got to be strong, but it's a silver bullet. In the OT world, we also had a silver bullet for decades. And it was the air gap, right? These systems, these critical infrastructures, they were physically separated from the outside world, so you couldn't access them. Now, believe me, I tried in my old jobs, right? One of my old jobs was to affect these OT systems as authorized by the President, the courts, and the Congress. But unfortunately, this air gap no longer exists in most of these OT systems, right? It's been bridged, convergence is happening, right? What used to be isolated and proprietary is now connected. So that means the need to recognize this cyber physical convergence is become much more urgent because two things have happened now. One, we have national actors, right, these states that I named earlier, that are very, very motivated and increasingly capable of attacking these critical infrastructures and OT systems. And at the same time, that the technologies converge them that connected IT and OT. So it's a bad time for this particular problem. All right, so this is what we're looking at today. You've got this person looking at this massive wave ahead of you and you say, how in the world am I going to survive that? But what we all don't realize is that it's just the first of things, right? These nation states that I'm talking about are not just going after these single stage attacks, but they're looking at very, very complex attacks coming at you from multiple places and multiple angles. So like one of my old bosses used to say, Rumsfeld, right? You need to have a strategy that addresses the known knowns, the known unknowns, and the unknown unknowns. So how does that translate to cyberspace? So I do have a pointer. So the known knowns in cybersecurity, that's about characterizing known malware, pushing out a signature, and making sure you block it before it can affect you. Shame on us if we're not doing stuff like that, right? Known knowns. Well, what about the known unknowns? Known unknowns are the things that you suspect are out there, you just don't know where they are, but you're pretty sure they're out there. So what you do there is, in the cybersecurity business, you use behavior-based technologies to go after the known unknowns. Pretty effective technology, and it's the natural evolution from signature-based to behavioral-based. Well, how in the world do you go after unknown unknowns? Unknown unknowns are, by definition, guess what? Unknown, right? So the best you can do is you posture your system to be able to adopt the new strategies, the new technologies when they are in fact invented. And I'll talk a little bit more about what they are, but it's fundamentally it's two things. You need to build your architectures based around number one, speed, and number two, connectivity. Because if you look back, and I might be getting ahead of myself, if you look back, the inventors of the internet, right, 50, 60 years ago, whatever that number is now, they built something new based on two things, speed and connectivity, right? So unless we as computer scientists or whatever, or scientists or planners we have in this room, unless we're optimizing around speed and connectivity, we're not doing ourselves any good. We have to optimize for the future prepare for the future, the unknown unknowns, by building around speed and connectivity. All right, so a little bit more on strategy. So what do you bring to a food fight? What do you bring to a pillow fight? What do you bring to a knife fight? And then lastly, what do you bring to the problem of cyber coming at you at speed and scale? Do you bring lots of people and manual techniques? No, you do not. You bring automation integration, right? The only way you're going to take on the problems of speed and scale are through automation integration. So again, it's something that, what you see, I'm just focusing on strategy right now. These are things we really need to embrace at our core of the strategies when we're planning for the problems of speed and scale. All right, so some people are asking me, Phil, you're talking about AI, and I, like a lot of us, I'm tired of the AI because it's so overused these days. So what I did is I put together this chart that talks about, well, what are our specific goals? Well, it's simplicity of cyber defense. And what I mean by simplicity, it needs to be both cost effective and very, very effective and efficient. And some of the strategies to make that happen is through speed and integration. You want to leverage automation. You need to do some other key things too, kind of boring things, but essential from a computer science perspective. And this is how you're going to get from computer science to science fiction. You need to make sure that we're grooming our data so that it's able to be manipulated wisely. We need to create some risk-based decision engines. We need to do a whole lot better at some of our behavioral analytics. This is the royal way. And at that point, you can get the leap-ahead result of artificial intelligence and use that in lots of different places, not only in the IT space or the cloud, but the OT space as well. But unfortunately, too many of us in the community today are mistaking or mismarketing things like automation for this. But there's still a lot more work to do from an AI perspective. My company is, in fact, very aggressively doing these things, and I think we're well down this path, but I just want to make sure we're all using the same definition of AI. So is this where we're headed? Where the machines will do this? And I like to think not. In fact, this looks more like a CEO CISO relationship. The role of the CISO is he's the person's neck that's going to grab in a crisis. But no, I don't think that this is what the future looks like. I think it's a much rosier future. Technology, including AI, is not inherently evil, right? It's neutral, right? It's how people use the technology, and so we'll figure that out. So this is my less scary path of evolution, and it's pretty much the continuum of information sharing. So we all got kind of comfortable a few years back about the idea of characterizing incidents and sharing the fact that you had an incident. And then we got smarter and said, well, here are the indicators, the things I saw in that incident. I'll share that as well. That's pretty cool too. And then we pretty much stopped. As a community, we stopped pushing this continuum of information sharing. Even Congress stopped, right? Congress passed, what is the CSIA? I forgot what CSIA stands for, it's information sharing, might be CISA. They kind of stopped here, but where we really need to be is going from incident to indicator to sharing the mitigation that worked. Or even better yet, can you abstract the mitigation in a way that can be acted upon even if I have a different configuration or a different architecture? And better yet, why don't we automatically ingest it? So to use a baseball term, what we have today, we have too many pitchers and not enough catchers, right? We have lots of people who are pushing this stuff out, but we don't have the systems and machines and strategies to automatically ingest them and do something about it. And of course, this is where we need to be. We need an automatable integrated response where you're using the technology under the control of humans, so you have humans above the loop, not humans in the loop. So we need to make sure that we don't get too kind of cozy and comfortable and patting ourselves on the back when it comes to information sharing, because here's where we really need to be. It's all about action. Oh, good. So I hinted at this earlier. So this is the most pretentious thing I hope I ever have to say. I'm writing a book. I've never written a book before. I'm writing a book for a company, and it's based around the following premise, that cybersecurity needs to be treated like a science. And what I mean is that, since you volunteered before, I could explain his coffee cup and its remnants and the sweat on it and other things on it through the fundamental sciences of physics and chemistry. Almost anything in this room can be explained by physics and chemistry. And we spent a lot of time over the decades or even centuries making sure that we understood what those rules or laws of those hard sciences are. And we've succeeded because of that. We've also failed by ignoring them, right? If you try and create a missile system or an airplane that ignores the law of physics, you do so at your peril. But we're not doing the same thing with computer security, cybersecurity, where it's still an art practiced by wizards. It's not where we need to be. We need to look at cybersecurity as a science and start writing down the rules and paying closer attention to them. So, sort of borrowing a page from the sort of the molecule style, I said, well, what are the fundamental elements of cybersecurity? And I mentioned this earlier. It starts with speed and connectivity, right? If you're in the cybersecurity business and you come up with a slow product, shame on you, right? You're ignoring the laws of cybersecurity, right? When you're in the cybersecurity business, you're fundamentally in the business of slowing people down. That's a pretty bad marketing slogan. Here, I'm here to slow you down. So you better be optimized around speed and the connectivity as well. When I used to do my work in my old job, we came at people from multiple angles, right? So why do defense is a point when the offensive folks are coming out as a team? So you want to be able to integrate your defense just like the adversary is going at you from a integrated perspective. So around that, where we need to be, treat this as science, we need to get the authentication problem right? We failed that 50 years. We've all been paying the price for that for a really, really long time. There's some other things we need to get right. I'll spend some more time on this later on. And here's where here's where everyone can do really, really well. There's no reason why we can't do well here, right? And again, I'll spend some more specific time on these things. These are just really, really good tools today that we ought to be using everywhere. It's the fundamental science of cybersecurity. Good segmentation, strong cryptography, and appropriately granularity access control. Once you have some of these things down, you've got an architecture built on speed and connectivity. You're trying to solve these enduring shortfalls that we're all struggling with. You've done these absolutely fundamental things. Well, there's more advanced things you ought to be taking on, such as making sure you have the right visibility, right? You can't defend what you can't see. You need to know what your nodes are out there on their network, how they're connected. You need to be able to do more inspection, right? So the good news is that encryption is becoming ubiquitous, right? Used lots of different places. The bad news is that it means that cybersecurity operators are going blind, right? A high-end strategy of cybersecurity is inspecting content, seeing what's going in and out of your network to see if you have IP that's being stolen or data, privacy breaches. See if you have adversary command and control coming in and out of your network. You really need to do the inspection. Well, the technique to do that is called break and inspect or SSL decryption. And the problem today is that, I'm going to brag a little bit about my company, the problem today is that this is being turned off because it's too slow, right? Because to do this type of work, this inspection, it's processing intensive. Let's go back to this. A number of years ago, my company, Fortinet, decided to be the fastest cybersecurity company out there. And we pioneered a new technology called SPUs. So we all know what CPUs are, right? Central processing units. You know what GPUs are? Graphics processing units. Those are things that were invented probably 20 years ago now that accelerate the processing of graphics on our PlayStations and Xboxes and now our TVs. We invented something called SPUs, security processing units. And they're custom ASIC chips that we've invested hundreds of millions of dollars in that we put in our products, and they accelerate the processing of security. So in some sense, it's like, duh, that makes a lot of sense, right? Rather than burdening a CPU to inspect traffic at the same time that CPU is trying to process network traffic and slows everybody down, why don't you create some special chips called SPUs, offload your security processing to them in a very, very high assurance environment, and accelerate the whole thing. So what I'm trying to say is inspection as a strategy is not dead. You just have to find the right products that's fast enough to turn it on. I really highly encourage you to keep inspection as a fundamental strategy of cybersecurity. And then lastly, it's even though I'm a technologist and I've talked a lot about technology things here, there's some higher order things that unless we get them right, we're probably still not going to do very well. And that's recognizing the human factor. no matter what, how well we do over here, if we do these things in a way that insult our inherent feeling of privacy, then our operators are going to be pressured to turn some of these things off. Or if we do all these things in a way that it's so complex that we start making mistakes, or we do, humans start making mistakes, this whole thing will fall to pieces. So whatever we do, we need to make sure we're harnessing this technology so the computers serve man, and man's not serving the computers. Speaking of that, does anyone remember the old Twilight Zones? It was before my time, but the black and white ones. I have a minute. So there's this great episode, tell me if you remember it. These 12-foot aliens come down and land on Earth. They're really, really nice to people. Does anyone know the episode I'm talking about? Mm-hmm. It's called To Serve Man. Yeah. And these aliens come down, they're really, really nice. They've got this book that they bring with them, but it's encrypted, it's triple des encrypted. Sorry, I'm making that up. But they can't read the book. And so the aliens persuade all the humans to take spaceship rides back to their planet. Everything's going well. And the scientists are able to decrypt the cover of the book, and it says, hey, this book's called To Serve Man. See, these aliens really they have a higher order purpose. They're going to help us out. And so all the human beings were, loading on the spaceships, and at the last minute, the scientist comes running up and goes, wait a minute, I decrypted more of it. It's a cookbook. So they're harvesting humans to feed their alien hunger. So that was an example of, I don't know what the analogy is, but we need machines to serve man, not men to serve machines. That's what I'm trying to say up here. Yeah, thank you. I got that slightly wrong. Alrighty. So let's talk a little bit about this one. I think I already did. We need to squeeze every single clock pulse of performance out of our security processors, because every time we're doing something, we're slowing others down. Again, that's a horrible business to be in. So unless we're the fastest around, then you'll always lose. If you make a user or an operator choose between security and performance, guess who's going to lose? Security's going to lose. Now here's how you can use this speed advantage. So the strategy, I call this my left of boom chart. It's an old military term. So the strategy of yesterday, from a cybersecurity perspective, is you'd kind of hunker down, you'd harden your systems as much as possible, and then when a bad thing happened, you were left with that undesirable state of cleaning up on aisle 9. We'd be left defending and cleaning up that mess. But the boom is where bad things happen. That's why this chart gets its name. You want to stay left of boom. You don't want to go on the right side of boom. And so the strategy that we kind of launched several years ago, and first took root in California and Washington, is something called active cyber defense. And it's where you automatically look at the status of your systems and where can you do automatic hardening and where you can do automatic defense in a way that you constantly stay left of boom. Again, boom is where bad things are happening. It's just a pretty important strategy, and we need to be working to do this very, very aggressively. But the next big thing after that is something I'm calling auto-resiliency, auto-regeneration. That's where you have real-time analytics that are looking for weaknesses to your resiliency posture. So today we talk about, from a network perspective, we talk about quality of service, right? How many nines of reliability might you have? What's the performance of your system, the reliability of your system? We ought to be measuring the quality of resilience in cyber relevant time and make constant adjustments so we can stay as far left of boom as possible. So that's what auto-resiliency is. Auto-regeneration is for those inevitable times where you do find yourself right of boom. What can you do to automatically regenerate to a known good security state and get it back up and running? Too often that takes way, way too long. So we need to find a way to leverage automation and speed to keep us as far left of boom as possible. And the only way you're going to do that is by evaluating signatures and evaluating behaviors in cyber relevant time, leveraging speed to do so. And what might you do with that? So this gets back to doing things at cyber relevant time. So the problem of the past, I'm going to say 15 years or so, and we're all guilty of this, is that we've run to best of breed solutions, point solutions, right? We've bought lots of these different things that do single things very, really well. They might be sensors or they might be analytics. And we bought lots of them. And that seemed smart at the time, but what we've learned is that the management of that, the complexity of that is just so great that we're spending more time, back to my other riff, we're serving the machines rather than the machines serving us. So the strategy of connectivity is about being able to observe, orient, decide, and act, COAs, that's a course of action, in cyber relevant time. So the strategy to do that is you can adopt, you can still black box these things, like here's a specialized function that's sensing, another one does analysis, decision making, and mitigation. But you need to think about going from sensing to acting at cyber relevant speed. Well, how do you do that? You can only do that if you have some way for these different things to collaborate. So this risk decision engine here can say, uh-oh, this is looking like a risky condition. Let's go out and command my sensors to collect some more information. Or let's tell them to collect it and then direct to analytic to go try to make more sense of it. You do that by having a fabric that connects these things together so they can collaborate, work together as a team. And lastly, the other part you need from a connectivity, you need some type of back-end processing to provide context, right? So it's really interesting to see things here, right, through your analytics, but you don't want to make important decisions without better context. That's true of anything in life, right? So you want to have some type of back-end that understands the threat and other things from a massive scale and is feeding those insights across the fabric and can point them out to any of these different places. So this is what connectivity does for you. It allows you to implement the OODA loop, observe, orient, decide, and act in the cybersecurity space. And any way you're going to be able to do that is having some type of fabric to connect all your different solutions. Segmentation. I'm just checking the time real quick. So earlier I talked about the boundary defense being dead or dying, right? For the reasons that we understand. Great, I didn't start my time. So we got till roughly 8:30, right? Boundary defense isn't a viable strategy as we used to understand it. The number one security strategy, I believe, is segmentation. More specifically, it's doing agile segmentation both at the micro and macro level. It's the most important cybersecurity strategy of our day. And it's because the borders aren't there as we used to understand it, but also the data is moving around in lots of different places. So here's a animated diagram that helps illustrate that point. So it used to be that we create this red boundary around our entire network, but today's strategy is more about taking that red boundary and putting the boundary around the assets no matter where they are. In doing so, quite honestly, with great agility, because today you might want to have a segment strategy that looks like that, but you might want to change that, and tomorrow it's going to look a little bit different. So this represents agile segmentation, be able to change your protection strategies I don't want to say real-time basis, but change it agilely and be able to do it both at the micro and macro levels. And this is pretty cool. First of all, it's not cool. It's important from a security strategy perspective, but the cool part of it is that this actually turns out to be a business enabler. So it used to be that if we were thinking about doing business for the first time, we were left with sort of the unenviable choice of sharing everything with each other as we explored that, or sharing nothing because we didn't quite trust each other enough yet. Well, through agile segmentation, we can now decide to explore doing business together and allow each other access to the information we need to do that analysis without opening up the entire farm for exposure. So segmentation actually has become a business enabler, not just a cybersecurity strategy. And the last bit of good news, and I'll kind of stop my giddiness about this, is that this is something you don't need to rip out your whole architecture to do and implement a new one, right? You can gradually implement segmentation as your budget allows. And you just need to make sure you're picking the right technology so you can do this with good agility, with good precision, without increasing complexity too much. So that kind of looked like an IT architecture, but I wanted to just spend just a minute on a different architecture. So we all know the ISO 7-layer model, right? We grew up with that. But if you're in the OT space, you don't have the ISO 7-layer model. You use something usually called the Purdue model. And the Purdue model, it's a layered architecture, but it has a different number of layers. And it's important that we understand what those things are so we're not talking past each other. So you have higher order stuff. This might be where you have your HMI, your human machine interface. You want to do some segmentation in these boundaries up here. But down here at level 0, level 1, This is where you have your field actuators, right? Think of this as the industrial IoT. I hate to intermingle OT and IoT, but these are where your sensors are, the things that sit on the motors and sit on the pipelines and such like that. These are, just like in the IoT space, these are relatively dumb devices you really can't put stuff on. And making it worse, they're connected through something called PLCs, programmable logic controllers. Similarly, the PLCs are really twitchy devices. You try and scan a PLC, you'll crash it. And that's the worst thing you can do in the world in an OT environment, is crash somebody. Because remember, it's about safety and reliability. So in the Purdue model, you're kind of handicapped because at layer 0 and layer 1, there's not much you can do. So instead what you do is you try and build more defensive stuff up here in the higher levels of the Purdue model. And quite honestly, it's consistent with the strategy I talked about earlier. The integrated defense, you don't want to have to do defense at the point of weakness, right? Whether it's IT or OT. If someone's coming at me at this point right here, my point of weakness, you don't want to necessarily do your defense there. Ideally, you'd move your defense to different parts of the architecture, defend at the points of strength, and by the way, do so in an integrated way. That's the model, that's the approach we're taking defending the Purdue architecture. We're saying, for now, we realize that we can't, do defense down here. We're working with OEMs at Fortinet to influence future generations of these things. So instead, we're creating connected solutions, integrated solutions that work at the higher level of the Purdue model. So anyway, I just want to get this on your radar. There's a thing called the Purdue model, so that we don't talk past each other. I mean, in some ways, I'm asking you to be ambassadors of OT IT integration, and the reason I'm taking advantage of my time up front of you today of talking this stuff to you is so that you can be informed ambassadors, because we don't want to go in and preach to others about IT solutions in the OT space. I pretty much covered this. This is more of a critical manufacturing architecture, again, where you can put different solutions at different layers of the architecture. All right, and to wrap things up, I wanted to give you my view of some of the relationships to the cyber-physical space, including sort of a view of the future at Fortinet. So today, this is what IoT looks like, right? There's roughly 3 classes of Internet of Things. There's the consumer things. These are the things that we're wearing on our wrists. There's the commercial things. That's where companies, sorry, I'm flattering you. Taco Bell is really big on, creating a really positive experience for customers that come into their network, number one, that want to use IoT. But just as importantly, they are instrumenting their outlets with lots of different types of sensors that will make them more efficient and effective in running their business. So consider that commercial IoT. And then earlier I talked about more industrial type stuff, things that might sit on a pipeline or a power generation plant, stuff like that. So there's 3 classes of IoT, not to be confused with OT. So these are some of the names that we talked about earlier. Things, SCADA, ICS, critical infrastructures, field sensors, and this is where they overlap, right? Where OT and IT overlap. I kind of hesitate to show this diagram because too many people say IoT and OT in the same sentence. And unfortunately, the defensive strategies for each are completely different. And so, there's some overlap, but the strategies used be very different. And then there's this last category that I'm simply going to call other physical centric. And they don't quite fit cleanly in OT and IT, but they are really important things are emerging, right? So, the Internet of Cars, or the internet in your car, building automation, huge business, right? The things that control our locks and our HVACs and stuff like that inside our buildings or homes, and of course healthcare. So I think this is a big part of what our future looks like, and it behooves us to understand that there's different solutions and different strategies for each of these things, but they all ultimately will be collaborating in some way. And that's what takes me to, I think, is my last chart, to illustrate of where we're headed at Fortinet, my company. So Fortinet started as a humble firewall company 20-ish years or so ago, and has done very well at building a whole variety of what I'll call infrastructure appliances that work in that space. And similarly, my animation's not keeping up my soundtrack. Similarly, we recognized a while back that it's not just about physical things that you're going to own. It's going to be about virtual things that you take advantage of, whether it be your own private cloud or public cloud or some hybrid example of those two. So Fortinet's very much in each of these domains, and importantly, seamlessly work across them. So almost all the solutions we have here also work in the cloud. So our slogan is, we secure IoT to the cloud. Well, we do. IoT is not there yet, but I'll say endpoint to the cloud. And we do that in a way without increasing complexity. So the way you would configure a firewall in your physical sense is the same way you'd configure a firewall in the virtual sense. So we're building across these two domains while managing complexity. But the thing after that, and I've been talking about it a lot already, is what I'm calling the cyber-physical domain. And that's where we'll be doing much more in the OT space, certainly IoT, industrial automation. In fact, depending on how you count it, already 20% of Fortinet's revenue is generated in the cyber-physical space, which is an incredible amount of revenue. We're in the order, I won't bore you with our revenue details, but it's a lot of money. And what I'm trying to say is that there's a real hunger to secure things in this space and, of course, do it efficiently and effectively. So cyber-physical is an important domain of ours. And so this is sort of what's on the horizon, and this is what I think is just over the horizon. So I told you earlier that we've invested in a number of custom ASICs, security processing units, security on a chip. We have about 4 different ASIC chips we've developed to accelerate processing in these spaces, where we're going to use those types of things for embedded. I think embedded is an important part of our company's future, where whether it be cars, medical devices, building automation, we're going to take these types of chips that worked previously inside Fortinet devices, and maybe in the future you won't even see that, right? Maybe at best you'll see is an Intel Inside label, Fortinet Inside label. And we're going to take security and push it all the way down inside things as they're built. So it's a pretty natural evolution as you see it. Physical appliances, virtual solutions, cyber physical, and ultimately embedded. So, I included it. Supported by services. And this is, I think, my last point, that what makes this really interesting is that all of a sudden you have a data stream coming from here, different types of data from here, different types of data from here. All of a sudden you're sitting on a tremendous amount of data that could be leveraged to create context that you could never get before, right? So you might be getting some information here, but wouldn't it be really great if you had the context of, well, what's happening in the cyber-physical space, or et cetera, et cetera. So all of a sudden, remember I talked earlier about data being the oil of the 21st century? This particular 4-domain approach is going to create a very, very rich data architecture, which that we hope to build some services that can make all these things more effective on behalf of our customers. So that's it. Hopefully what I covered was some definitions, some characterization of threat, especially the cyber-physical threat, and some strategies. And I would really, really ask you to make some new friends in the OT space, because our worlds are not colliding, our worlds are converging. And we have a lot to learn from the OT folks, and they have a lot to learn from us, but only if we talk with each other and, as professionals.